All right, hi everybody. Today we're going to talk about Objective 2.5, which is about modeling and solving linear equations. So we've actually worked in Unit 1 with modeling, but now we're going to be modeling with equations, and we're going to be solving those equations. All right, so let's review Unit 1. Translate the following verbal expressions from English to algebra. So a number r increased by 10. Recall that increased by means addition. We're going to add. Okay, so r increased by 10 is going to translate to r plus 10. Okay, number 2, a number b is subtracted from 2. This should say from, not by. Remember, when we see subtracted from, we need to switch the order. So subtracted from is going to be 2 minus b, not b minus 2. Okay, number 3, 3 times the sum of a number and 2. So here, they don't give us a variable, okay? In number 1, they gave us r, and in number 2, they gave us b. In number 3, they don't give us a variable, so we have to write what we call a let statement. Let x equal the number, okay? And then 3 times the sum of a number and 2. The sum of a number and 2, remember that we have to put sums in parentheses. So the sum of a number and 2 is going to be x plus 2. And then 3 times that is going to be, in parentheses, the whole thing multiplied by 3. All right? Number 4, twice the difference of a number and 3. Recall that we need to put sums and differences in parentheses. So the difference of a number and 3 is going to be x minus 3. And then twice that is just going to be 2 times that entire thing. All right? So, modeling using linear functions. Equations modeling is using information and math to construct equations that model real-world applications. So we're going to be dealing with a situation, and we're going to have to write an equation to model that situation. 2 important pieces of information are needed to create a linear model. The first one is our initial value. Now, what does that mean? Well, we're going to talk about that in a minute. But initial means starting value. So our initial value. Starting. And again, we're going to talk about what exactly that means in a minute. But that's one thing that we need, is we need our starting value. Some keywords are fixed, initial. If we see the word initial, that means initial value usually. Start. All right. Begin. You see any of these keywords, that means that this is our key value, our initial value. Okay, down payment. If we're talking about a money problem, all those mean that that's our initial value or our starting value. The next value that we need is our rate. Some keywords to indicate that we're talking about rate are each, per, every, or we might even see the actual word rates. Okay, so now what the heck do these words mean? Well, we're going to see in a minute. Okay, let's take a look at 2 examples, and then we'll be good. Okay, so a factory incurs a daily fixed cost, so I see a keyword there already, fixed, of $200 plus $15 per widget that is produced. Let's model the situation using algebra. So they're asking us to write an equation. Okay, so we need 2 let statements. I'm going to let W equal the number of widgets produced, and a widget is just like something, anything, a device. I'm not actually sure what a widget is, but it doesn't really matter. Okay, the number of widgets produced, and C is going to be total cost. Okay, so this means that the factory is getting charged, or it's costing the factory $200 no matter what. So that's our initial value. And it's $15 per widget they produce. So if I produce W widgets, okay, our cost is going to be, well, we're going to multiply 15W to get the amount of money that we have to, or that we're charged, or that we spend per widget produced. plus $200 that we're getting charged no matter what. So our initial value is always going to be by itself, and the rate is always going to be multiplied by the variable, right? So now, if we know that 85 widgets were produced yesterday, what is the factory's cost? They're telling us that the number of widgets that we produced was 85. They're giving us a W value. We need to find the cost C when we produce 85 widgets. So what we're going to do is we're going to plug in 85 into our equation. So we have 15 times 85 plus 200. All right? So 15 times 85 is going to give us, let's see, 15 times 85 is going to give us 1,275. And then 1,275 plus 200 is going to give us $1,475. So that means that if we produce, or if this factory produced 85 widgets, it would cost $1,475. All right? So if we know that the factory's cost, so now they're giving us a cost of was $2,000, how many widgets were produced? So what we have to do is they're telling us that our cost is $2,000. So we need to take that $2,000, take our same equation, 15W plus 200. We're going to plug in 2,000 for C this time. Now look at this. We have to solve this two-step equation. All right, so I'm going to subtract 200 on both sides. That's going to give us 1,800 equals 15W. And after I divide both sides by 15, I'm going to get 120 widgets equals W. So that means that if they spent $2,000, they tell us that we spent $2,000, that means we produced 120 widgets. Okay? All right, number 2, second one. Maggie earns 5 bonus points with extra credit. 5 bonus points towards her upcoming exam grade. Each question on the exam is worth 4 points. So look at that. I see the word each, I see 4, and I see that she earned 5 points before anything even happened. So write an equation to represent this situation. So here, we're going to let Q equal questions, or lowercase q. Let me write lowercase q. The questions answered correctly. And then we're going to let G equal her grade. So now her grade, G, is going to be 4 times the number of questions she got correctly, Q, plus the 5 points that she initially had from her extra credit. So now, whenever we're writing an equation, right, this is the general form that we're going to be in. Final amount equals our rate times our variable, whatever that may be, plus our initial value. So our initial value is always going to be by itself. Our rate is always going to be attached to the variable. Okay, so rate is always going to be attached to the variable, and our initial value is always going to be by itself in our equation. Okay, Maggie feels like she answered 18 questions correctly. Use the model to find her grade on the test. So they're telling us that Q is 18. So we're going to take our equation, and we're going to plug 18 in for Q. So we have 4 times 18 plus 5, and that's going to give us 77. So if Maggie scored 18 questions correctly, she's going to get a 77 on her test. Okay? Now the next question says, if Maggie found out that she earned a grade of 93 on her test, how many questions did she answer correctly. So now they're telling us that her grade is 93. We're going to use our same equation, G equals 4Q plus 5. And now we're going to plug 93 in for our G, and we're going to solve for Q. So we have a regular old two-step equation. We're going to subtract 5 on both sides. Okay, we're going to get 89 equals 4Q. And then after we divide both sides by 4, we're going to get 22 equals Q. So that means that Maggie got 22 questions correct. If she scored 93. Okay, so ladies and gentlemen, that's modeling with linear equations. Hope you guys have a wonderful day. As always, please don't hesitate to reach out with any questions.